So what I want to do is I'll give you some hints about the written section, fairly blatant, and then I'll also talk about specific examples. So on the written section, certainly you can expect to use orbits, and you can find R, T, V, or altitude. Or if I give you two of these, find big M, for what it's worth. All of them start out with what? All of them start out with, hey, if you know you're in orbit, what's our standard approach? Gravity equals centripetal. Gravity equals centripetal. And then that can branch off into two possibilities. You can either go big G, big M, little m over R squared equals mv squared over R, or big G, big M, little m over R squared equals m 4 pi squared R over T squared. Remember, on your formula sheet does not appear on your formula sheet. All that appears on your formula sheet is centripetal acceleration. So please make sure if you want to turn it into a force, you multiply by mass. Every year I see some kid every year who does this because they're so used to the mass canceling, but they wrote the mass in the first term, and now the mass doesn't cancel, and he didn't give me the mass, and I don't know what to do. Right? Don't do that. Okay? From this one, get the R by itself. Give you a hint. Get the R by itself. Really? Okay. Yes? Right? Yes? So at least for starters, I would have big G, big M, T squared equals 4 pi. Oh, wait a minute. Why write the 4 pi squared when it's going to divide over here? And that equals R cubed. And how would you get rid of a cubed? Oh, boy. Doesn't help if I go right through the squared. Okay. There's getting the R by itself. Getting the T by itself, it's going to be similar, but you'll have a T squared by itself. I think the T squared is going to move up. The big G, big M moves to the bottom right. R cubed moves up, square root. This one was a lot easier, and we've done that one the most, so I'm not going to do a specific example of that one there. Do you want me to do a numerical example, or are you okay once you get to this stage of being able to plug in the numbers? I mean, it's a lot of typing, okay? What else might you see? Work. How, you got to go? Okay, sorry I couldn't start earlier. Anyways, it'll all be online. How? Oh, you're serving your detention. I thought you were here to learn. My mistake. I won't make that mistake again. See you on time Tuesday. Yeah. How much work to lift versus how much work to put in orbit. So let's do an example. How much work to lift 1, 2, 3, 4, well, 1, 2, 3, 0 kilogram satellite to altitude of 3.3 times 10 to the 6th meters, question mark. How much work? Are we in orbit? Nope. So the work is going to be but I'll be able to do that if we're just lifting it up there, we haven't given it any kinetic energy. In fact, it will come crashing back down to the Earth if we let it go, and that's why, Ashley, I pretended little visible angels or something are holding it up there. Changing anything is what? So, work is going to be negative big G, big M, little m, over R final minus negative big G, big M, little m, over R initial. I have a lovely minus minus, which is plus. And this question is going to be, a fair bit of typing. So let's see. Work is going to be, I wondered,
Thank you.
negative 6.67 times 10 to the negative 11. Mass of the, if I don't specify a planet, assume it's the Earth. I know on your written, there's at least one question where I went to the moon just because I wanted to dream big. Mass of the Earth is 5.98 times 10 to the 24th. Mass of the satellite was 1230. Looks like my final distance from the center of the Earth is the radius of the Earth plus the altitude. Oh. And altitude. That's why it was bad grammar. My English should have been more gooder. Plus, and this is about the only time in the interests of time, Callum, where I've said, okay, go ditto mark times ditto mark times ditto mark divided by, and I guess my initial is just going to be 6.38 times 10 to, I started off from the surface of the Earth. And the other reason I don't mind, Josh, those ditto marks is what I've told you. I hope by now you have a decent calculator that actually just lets you backspace and edit and save yourself some typing and time. And really, it cuts down on your mistakes because the amount of typing, the more you type, the more likely it is you hit the wrong key accidentally, right? So it's going to be, of course, you can get your calculators out and follow along like I suggested you would at the beginning of this tutorial. Negative 6.67, negative 11, times 5.98 to the 24th times 1230 divided by bracket 6.38 times 10 to the 6th plus 3.3 times 10 to the, geez, Dueck, 6. I think your final potential energy, double check, double check, double check, double check. Can someone confirm with me? Did you get negative 5.0682 times 10 to the 10th? Negative 5.0682 plus, and wonderfully, I think I should be able to just backspace and go delete, 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 delete. Right? Ignore the negative. I forgot to delete the negative. So plus 7.687 times 10 to the 10th. Looks like the change in potential is going to be, okay, I need to make this positive. There, times by negative 1. Now it's positive. There's another way to delete a negative in a hurry. It's going to be that plus negative 5.0682 times 10 to the 10th. Or again, Ryan, instead of going plus negative, I could have just gone minus, right? The work to get it up there, 2.6215 times 10, 2.6215. Final answer would be the 2 or 3 sig figs. That was how much work to lift it to an altitude of that. Hey, what if I said A, how much work to lift it to an altitude of that, and then said B, how much work to keep it in a stable orbit at that altitude. Still asking me to find how much work? Okay. So it's still going to be change in potential, change in kinetic. This time they don't cancel. I have to have kinetic energy to stay in orbit. Thankfully, I just finished doing the change in potential. The change in potential was 2.615 times 10 to the 10th joules. What's the change in potential going to be? Well, that's going to be, sorry, not what's the change in potential. Good gosh, Dueck. What's the change in kinetic going to be? That's going to be a half mv final squared minus the initial, but let's assume we start at rest, Neve. Which is going to be a half m that. Did I give you the orbital speed? I could have. I did on the quiz. Did I in this question? Nope. Okay. To find the orbital speed, gravity equals circular. We've done this a few times. In the interest of time, can I just say I'm pretty sure orbital speed ended up being big G, big M over R, square root? Or you know what? Actually, I don't want to get the V quite by itself for this question, because what do I have in my expression over here, Sam? A V what? Squared. Hard. Oh, she's not here. So, hey, let's do that. In which case, I find the change in kinetic energy is a half m big G, big M over R, which is almost the numbers that I've already typed. It's going to be R final, because it's V final. So it's going to be a half 6.67 times 10 to the negative 11, mass of the Earth, mass of the satellite, divided by R final, which was 6.38 times 10 to the 6th, and an altitude of 3.3 times 10 to the 6th. Again, I can't remember if I said this already. I won't always give you the altitude. I might sometimes give you the radius, the orbital radius, which is easier. Then you don't need to add the radius of the planet. You're good. Okay? I think if I go backspace, 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 and one more, hey, that's the one that gives me almost all these numbers already. I just have to delete the negative. I got the 6.67, I got the mass of the Earth, mass of the satellite, divided by the radius, and then half of that, he says cleverly. 2.5341. The change in kinetic energy, 5341 times 10 to the 10th joules. So the total work is 2.5341. The change in kinetic plus the change in potential, which was 2.6215 times 10 to the 10th plus 2.6215 times 10 to the 10th. Total work is 5.16 times 10 to the 10th joules. That's really going to be the written section when it comes down to orbital or work stuff. The only other thing is I could drop an object from space. Is there a change in height, speed? It's not a yucky, curvy path, but the fact that the force is changing, yeah, it's a job for conservation of energy. I can't just go to free fall. So it would be kinetic initial plus heat if the question asks, hey, how much did you lose to friction, or mentions friction. Usually in outer space, though, we'll assume no heat. Okay? And the only key is negative big G, big M, little m. Please use the cosmic potential energy. And really from this, actually I can do one of two things. I can give you my initial how far away from the center of the Earth, or I can give the altitude, add the radius of the planet, and say how fast does it hit the ground at. In this case, if it hits the ground, potential final is not zero, not under our universal relative to zero potential energy equation. Or, yeah, or I could tell you how fast it hit the ground at. How high did it start? Now you have to solve for R initial, which is on the bottom of a fraction. It's a bit yucky. Is that what you're going to ask?
I'm going to ask, there's going to be one using the conservation formula. We have to find like the R final or R initial.
Could be. The way I would do that, so let's just write down, suppose we want R initial and KE initial is 0. Let's also suppose we started at rest. We somehow magically dropped a big asteroid from outer space. Kind of cool, in a creepy sort of a way. You'd have this, negative big G, big M, little m over R initial equals a half mv final squared plus negative big G, big M, little m all over R final. Okay? I would have to tell you V final, okay? What I would do then is I would crunch that to 5 or so sig fig. I would get an answer. I wouldn't yet get the R by itself, and so you would have this, negative big G, big M over little m divided by R initial equals, and I know this would be negative. The reason is I know the radius has to be positive, so somehow the negative has to be canceled. Negative some number, okay? And now what I would do is I would times by R initial and divide by the number. So now what I would do is I would say, now I can move this to there and move that to there. I would not try and get the R by itself before I went any further. It's on the bottom of a fraction. When you have one fraction equals one fraction, piece of cake, but now I have one fraction equals two fractions, yeah, forget it. You could, I mean, if it was Math 9, I'd teach you to multiply everything by the common denominator and clear the fraction. Forget it. We're not interested in technique. In fact, we will eschew good technique for faster results here if we need to.
Yeah, there was a question like that in lesson 7.
And no one's asked me about it, and so I thought either they skipped it or everyone got it. Yeah.
You go on your review answer page and find a question like it to figure out how to do it.
Yeah, and I think there is one where you had to find, yeah, okay. And I think I probably would have almost certainly done the same thing. I don't think I would have got the R by itself.
And it was in the scholarship tricky.
Yep. Okay. So I'll tell you what that means. I would feel okay with this probably as a nasty multiple choice more than a 7-mark written. Okay. Again, I am really big on every one of my tests, there should be one really nasty multiple choice. And it's not that I don't want you guys to get perfect. I do, if I can teach you one thing this year besides the physics, it's what will you do when you don't know what to do? Because in university, unless I have one or two freaks in a positive way, every year I got a couple of freaks that are going to get 99s in university too, but most of the time you're going to find when you get to university, the 99s don't come so easy anymore. What are you going to do? And hopefully if I can give you some skills to just not panic, the phrase I hope you've heard me use is stubborn and clever, which if I can inculcate that into you, then I'll call myself a good teacher. Then I've done my job. I just haven't found a way to do it painlessly yet. I'm sorry. Hence the, every time, yeah, number 7 is the nasty, or you'll find that there is a nasty on this one too, although it's a really cool one because it's like outer Star Trek guy. Cool stuff. Good stuff. I think safely you can say the nastiest ones are usually the coolest ones too. Okay, so this would be okay as an upper level, fair game, multiple choice. All right. Dropping an object. So those are really the cosmic things I can throw at you. Now there was sort of a cosmic thing. We did look at the space station artificial gravity, but that was really saying normal force became circular FC. And normal force, we just said on the Earth was, what's your normal force normally? No pun intended. mg. So we didn't have to go cosmic and bring out all the other changing forces or anything. Sure, that would be fair game. What else? Amusement park rides. Okay? So, conveniently, I think I found one. Yeah, here we go. Because I can't draw these to save my life. Okay, here is my amusement park, my Gravitron. Right? And I think I told you it's either going to be Gravitron, Ferris Wheel, or roller coaster. To be honest, I think probably 2 of the 3, because I have nuts about amusement park rides. In fact, probably Gravitron, Ferris Wheel, or roller coaster loop. Probably. Okay. I'm going to set this up. And then we're going to reach a point where we stop, and then I'm going to say, look at the equations. Either I'll give you this and you can find that, or I'll give you that and you can find this. And the way we set this up, we're on the Earth, so we don't need to go cosmic universal gravitation. We said forces. What are the forces acting on this person? Free body diagram. And I'm going to draw the free body diagram side view right there. What are the forces acting on this person? Get the obvious one. Okay, so we have, is this person sliding down? No, the question says such that the person what? Does not fall. So there must be a force pointing up. I don't know yet. Let's come back to that. What path is this person tracing out? So there has to be a force pointing towards the middle. What force is what's pushing him in a circle? So in this equation, we have this. We have normal force equals m. Probably, well, if you ever go on this ride, getting the speed is tough, but getting the period is easy because you just time how long it takes somebody to go around once, and you can do that pretty. So I'm going to use the period one. So what else? Well, there's another equation in this free body diagram. I've written the horizontal force equation. Normal force is what's pushing me in a circle. Vertically, what can you say? Where friction is what times what? Right? I don't know the normal force. Oh, but I can get the normal force by itself, which is what's sitting in this equation over here. How would I get and this is different. Normally we always said, look. Oh, normal force was mg. In this case, it's, I don't know the normal force. I can't get, but I do know mg. How would I get the normal force by itself? How would I get the normal force by itself? Yeah. So I end up with this. Ha! What do you notice? Fat people can go on this ride as well as skinny people. All right, now how many variables are there here? G is not a variable. What's G on the Earth? By the way, what's the fancy name for that G? Okay, gravitational field, and it can be calculated. I should have mentioned that. Make sure I mention that. That will also show up on as a cosmic thing. It can be calculated as big G, big M over R squared. Mass cancels. So here I can either, well, in the question I gave you R, so R is not a variable. I can either, given T, or because pi is not a variable. Something like that. Or I guess I could give you mu and t and say, what does the radius of this ride have to be? I guess, okay, fine, sure, you could also solve for r. Okay? So that's one possible ride that we could analyze. Do I need to, you guys okay? Do I need to make up numbers? Or you could get the t or the mu by itself because it is 1 fraction equals 1 fraction? Yes? We're good? You'd square root to get the t by itself eventually, right? Ferris wheel. Did I find a good picture of a Ferris wheel? Oh, heck. Draw. Circle. Ferris wheel. Suppose let me make up reasonable numbers here. Sure. R equals 8.5 meters. Yeah, that seems about good. And suppose the period, it rotates every 24 seconds. If a person has mass 58 kilograms, find their apparent weight, also called the force from the seat, also called the, hey, what force are we talking about here? Oh, all right. I told you about the provincial exam, find the normal force question. Years ago, I was marking Physics 12 provincial exams, and the question said, find the normal force. And a kid wrote in their answer, which was funny, but they got a 0, you know. Oh, you get some, marking, especially marking the Math 12 provincial, you would get some kids that had realized that they had just crashed and burned. And so by the time they got to the written, oh, they were in bad places. They were in bad places. And sometimes they could handle it humorously, and they would write little stories and pictures. And, you know, one person had clearly written, was writing his paper the day the Canucks traded for Roberto Luongo because he answered every question with drawings of goalies. And Roberto Luongo is coming to the Canucks. Turn the page. Roberto Luongo is, I have no idea, but Roberto Luongo is coming to the Canucks. I'm going to get 0, but it doesn't matter. Roberto, okay, fair enough, you know. Then you get the other extreme. You get some people who you can almost tell just as you open their paper, this is going to be a perfect, because each question is done in different colored ink. And every heading is highlighted in a nice straight line, and all the lines are done by a ruler, and they've done it in pen just because they can. Bring it on, as opposed to pencil, you know. So they're fun to mark. Now they're all multiple choice. Yeah, so you guys know, the grade 12 provincials used to have a huge written component, which I thought was way better, because why shouldn't you have to defend your answer? I think, also, let's be honest, on the multiple choice, statistically, if there's 4 answers for every question, If someone knows nothing, what should they average on the test as a percentage? It should be 25. You know what? If someone knows nothing on a written, what really should they average on a written? If they should. They should. I mean, on the multiple choice, you're all getting a 25% bump? Come on, we can do better than that. Anyways, I'll shut up. So, let's find the normal force at location A. How would I do that? What are the forces acting at the top? Get the obvious. Oh, by the way, please notice. So Ferris wheel, good. I did kind of say roller coaster. No, I'm going to take that back. I might give you a roller coaster to analyze. Now, if I do that, which way is your head pointing at the top in a roller coaster? Downwards. Which way on a roller coaster is the normal force pointing at the top? Downwards. Now, in a Ferris wheel, the normal force is always pointing which way? Up. Right? So what are the forces acting at the top? Gravity down. Why is that a terrible free body labeling? Darn right it should be, because it's got to be pointing. And you know, you've had me long enough now. I like to exaggerate a little bit so I don't do something silly. What would the equation be on the top then? Who's winning? Right? Mass doesn't cancel here because actually your normal for how heavy you feel does depend on what your actual mass is. A skinny person will feel lighter. A heavier person will feel heavier. Okay? It's all proportional, but that's how it works. And I would end up with normal force equals, I would mg minus m4 pi squared r over t squared. In other words, I would go plus that to there and minus that to there. Right, Neve? Right. At the bottom, gravity down, normal force up. Hey, at the bottom, the normal force is equal to m4 pi squared r over t squared plus mg. And if you normally, no pun intended, feel mg as your weight, oh, you feel heavier at the bottom, lighter at the top. If your head is pointing down at the top, and I say something like, you barely made it, what am I really trying to say when I say, what's the minimum speed, or barely made it? Normal force is 0, because you feel weightless. You're not. Mg's still acting on you. But again, remember, Jacob, what you think of as your weight is not gravity. Otherwise, when I jumped out of an airplane, I would have still felt heavy, because gravity was still clearly acting on me. Have I mentioned I jumped out of an airplane? Okay. Roller coaster, like Ferris wheel, but Fn is also for a fight. Instead of a roller coaster, fighter pilot, same idea. String, rotating, mass on the end of a string, except in that case it's not a normal force, it's tension, but same idea. Certainly those three examples are fair game as a good vertical circle. Okay, so vertical circles, it's either going to be Ferris wheel, roller coaster, mass on the end of a string, and the other one that I mentioned that I've forgotten now that I thought I mentioned another one in there, didn't I?
Gravitron?
No, it's horizontal.
Yeah, okay.
Can't remember. Okay. That's really the written section for the most part. Let me look at my notes here. Yeah, okay, so looking at my notes here, roller coaster, like vertical, like Ferris wheel. So vertical circles. Ferris wheel, roller coaster, loop, or fighter pilot. Or I think in your homework there was even one, a car going over the top of a circular hill. That's a vertical circle. Okay, analyzing that. Horizontal circles, the gravitron ride, the space station artificial gravity, and definitely car going around a circular corner. And then there is the weird one. Small mass on a string with a large mass hanging from it. Like this. I got to go hunting for it. Bear with me. In fact, I'm even going to pause the video because it's going to take me a couple of minutes. So something like this picture here. Okay. Suppose if r equals 0.63 meters, find speed of the little ball. Okay. This is technically a horizontal circle with an Atwood machine vertical component. How would I do that? Well, suggestions. How would I start this? Yeah, I would say big mg down, tension. And I guess I got tension going this way because the tension always came in. In fact, tension is what's pulling it in a circle. I do also have little mg down and normal force up, but they're going to cancel out. I think what I really have as an equation is this. Tension equals mv squared over r. And I know to use the v squared over r because it said find the speed. Problem. I don't know tension. Or do I? Which mg? Yeah, if this is in equilibrium, those two must be canceled because those are the only two forces acting on it. I can actually say, aha, here, tension equals big mg, and I can plug that in. Big mg equals m, little m, v squared over r, and now I could solve for v. I guess it would be times by r divided by little m square root. Okay. There's an example of a circular, of a horizontal circle. I guess looking at my notes, going back to my, is there a change in height? Not just dropping an object from space. I could also launch an object from Earth and simply say, how high does it go? What would its final speed at the top be? If I launch something straight up. 0. It's still going to be a change in height changes, but your final kinetic is going to be 0. If I told you your initial launch speed, and that's where I could say, find R final. That would be a more interesting question. Pardon me? That would be a medium tricky. Yeah, I'd consider that a A minus, A level question. Not quite an A plus, but close. Yeah?
Will there be a horizontal circle where you have to use head, sun, and toes? Like any trig?
Will there be a conical pendulum? So someone asked, what about the conical pendulum? So you're talking about something kind of, sort of, kind of like this. Okay? Yeah? Let me make this a bit smaller. Oh, I forgot to unfreeze the screen like a meathead. Let me unfreeze the screen. There you go. Okay. Like that. First of all, how would you analyze this? What are the forces acting on it? That's it. How would you add those together? How do I know to stop right there? Because apparently if I'm moving in a horizontal circle, where must my net force be pointing? Got to be pointing towards the center, and it's got to be horizontal. So I know don't draw tension longer or shorter. Stop when it's going to add up to give you a horizontal line. That angle there would be 33 degrees. This asks, what's the period? Okay. I guess tan of 33 equals FC over mg. Really, tan of 33 equals m4 pi squared r over t squared, all divided by mg. I think you find the mass cancels, even if you didn't, they gave you the mass, but it cancels. To find the period, I probably could. Having said that, the reason is I used to always put it on the circular motion test, but that was when I did equilibrium, the unit that I temporarily skipped, in the correct order. And in there, we looked at a lot of questions like this that weren't going in a circle, but they were hanging at a weird angle. We got good at analyzing them. And so this was a natural, honestly, pretty easy progression, almost a boring progression. I don't feel comfy throwing this at you cold right now, so I nuked it.
Okay, thank you.
Okay? It's still pretty cool, though. It was the flying pig. So that's kind of a quick rehash of any other questions, any specifics from the review or from the homework that you're going, nah, I'm not so sure how to do that. Now is your chance. If you really want to see me, if you want to watch me go through everything, it looks like, because I printed up my notes from my 2011 and 2012 tutorial, in particular the 2010 tutorial, I don't have the notes for, but I quickly looked through the one that I sent you. That seems to me be me reteaching everything kind of from scratch. So if you're really stuck, feel free to watch those. Today I was more interested in dotting the I's and crossing the T's, but not teaching you how to read, right? Did you have any questions you wanted me to go over? Okay, let me just pause the video first.